All right, good morning, Tigers. We are going to be working on lesson 3.2 in solving inequalities, and this is straight up just practicing how to solve inequalities. If you can solve an equation, you can solve an inequality. So, and if you weren't able to solve equations in the last activity, well, look, this is a refresher. So, it should not be a very difficult lesson. I'm hoping we can kind of just breeze through it. If you would, go ahead and take a minute to annotate your learning target. So go ahead, pause the video, and take care of that for me, please. All right, so far what you should have is that you can create equations and inequalities, use them to solve problems, use equations and inequalities to represent constraints. So this is probably going to be the more confusing of the learning targets. Constraints mean like limits or boundaries. Like you're going to use inequalities to say, okay, you can't go past this number, or you can only do things between this number and this number. So it's to kind of represent your boundaries. You can interpret solutions as viable or non-viable, which basically means, is the solution correct or incorrect? Does the solution make sense or does it not? Is the solution okay or is it not? Does this number work as a solution? And then the whole meat of the activity, I can solve linear inequalities in one variable. Okay, so let's move on to our anchor challenge. So Chloe and Charlie are taking a trip to buy some things for their new puppy. They know that they need a bag of food that costs $7, and they also want to buy some new toys for the puppy. They find a bargain barrel containing toys that cost $2 each. Okay, so we've got Chloe and Charlie. They're going to buy dog food and some toys. So write an expression for the amount of money they will spend if the number of toys is T. Okay, so they have to buy the dog food and then they can buy however many toys they can afford. So how much does each toy cost? $2. So we'll spend $2 per toy, so 2T. Now, they need to buy the bag of dog food. Just think about if your mom gave you 20 bucks and said, hey, you can go grocery shopping and get you some snacks and stuff, but make sure you buy a carton of milk. If you didn't come home with that milk, what would your mama do? I know mine would tear me up. She'd tear my behind up. I'm just saying. So they can't come home without that dog food. So they have to spend the $7 on that dog food. So 2T plus 7. So that's how much money they're going to spend depending on the number of toys they buy. All right, so Chloe has $30 and Charlie has 1/3 of this amount with him. Okay, so we want to know how many toys they can buy, how many they can afford to buy. So we know Chloe has $30, but we don't really know how much Charlie has. We do know that he has 1/3 of that. So to figure out how much Charlie has is we're going to multiply this by 1/3. All right, so 30 times 1 is 30. So we have 30 over 3, and 30 divided by 3 is 10. Now, a lot of people are going to say, well, Miss Gallant, why didn't you just divide by 3 in the first place? That's basically what I did. And some people, like when they see 1/3 and they're like, oh, fraction, and they freeze. Right here, 1/3 is the same as dividing your total by 3, and that's fine. If you did it that way, great. I'm so glad that you saw that. I just did it this way because I know a lot of kids freeze when they see fractions. I'm hoping by the end of the year we are over that fear. Fractions, I want us to be fearless of fractions by the end of the year. We'll see. That might be a lofty goal. Okay, so Chloe has $30. And Charlie has 10. So how much do they have together? $40. So they can spend up to $40. So we want to write an inequality for the number of toys they can buy. So, or let's just think about this. We know they're going to spend 2T plus 7. And they only have $40. So this is how much they spend, this is how much they have. Which number should be bigger? Should they spend more money than they have, or should they have more money than they spend? If you spend more than you have, you're going to be in trouble with the store. They're not going to let you spend more than you have. So we're going to do this, we're going to make sure it's a less than sign. Now, can they spend exactly $40? Yeah, that's fine. I wouldn't, but they can. So we're going to put an equal to bar there. So this is our inequality. This 2t plus 7 is less than or equal to 40. Okay, so let's skip on down to task 2, which is straight up solving the inequality. Chloe suggests that they guess and check to find the number of new toys they can buy. Use Chloe's suggestion to find the number of new puppy toys they can buy with their combined funds. So, let's go ahead. I want you to pause the video and just use guess and check. So just start guessing numbers, plugging them in, and seeing how many you can buy. Okay, so I did some guess and check here. What I did was I just started plugging numbers in. Now I didn't do the math for all of these on the side because it was going to get messy, so I just did the math for the first one. So I randomly said, okay, let's try 8. So I plugged 8 in for T. 2 times 8 is 16. 16 plus 7 is 23. 23 is less than 40, so we know we can buy at least 8. Then I decided to jump up a little bit and guess 20. Well, 20... if I plug it in, it's going to cost me $47. So 20 is too high. Then I tried 15 and got to $37, which is really, really close to 40. Went to 16, that would be 39. That's close, but still less. And then I plugged in 17 and got 41. That's too high. So 16 toys was what I came up with. You could have guessed and checked a different way. You could have done it the exact same way I did, but with different numbers. But we should all get to the point that 16 is the most toys we can buy without spending over $40. All right, so number 4, Charlie remembers that they could use algebra to solve inequalities, just like you would solve an equation. Solve the inequality you wrote in item 2, treating the inequality symbol as though it were an equal sign. So we're going to rewrite this. 2t plus 7 is less than or equal to 40. So I want you to solve this. Solve it just like you would solve an equation. You can write your do and undo list if you want. Or you can just start solving. But go ahead and start solving this equation just like you would, or solve the inequality just like you would an equation. Like just pretend that's an equal sign instead of a less than or equal to, and see what you come up with. So go ahead and pause the video and try this one on your own. Okay, so this is what I came up with. I made a little do and undo list, and then subtracted 7 from each side, divided each side by 2, and I came up with t is less than or equal to 16.5. So solved it just like an equation. All right, so let's go on to the next page. Okay, number 5, did you get the same answer using Charlie's method as you did Chloe's method? So let's look. When we did Chloe's method, we got a total of 16 toys. When we did Charlie's method, we got 16.5. So those are not the same answer. So let's think about this. Why would I get 16 with Chloe's method and 16.5 with Charlie's? So Charlie's, we solved it like an equation. We got the exact answer. We got what would give us exactly 40. So $40. So anything less than 16.5 is an answer. That's a possible number of toys we can buy. With Chloe's, we were a little more logical though. So if you think about it, let's say you go to the grocery store, or let's say you're going to the pet store like they are, and you're buying all these doggy toys, and you want to spend exactly $40, are you going to be allowed to cut a toy in half and say, okay, I just want to pay for the top half of this toy? Pet store owners are going to look at you crazy, make you pay for the whole toy, and you're going to be in a lot of trouble. And you're probably going to get banned. So I don't suggest doing that. So 16.5 is not a viable answer here because you cannot purchase half of a toy. So even though mathematically Charlie's answer is more precise mathematically, logically it doesn't make sense. This isn't an instant where a decimal answer makes sense. So Chloe's method actually makes more sense. So here's my suggestion. It's not even that Chloe's method makes more sense. Like Charlie's method makes more sense, but when we think about the problem, Chloe's answer is better. I'll tell you, this one took me less time to work than this, and I could have been guessing 1, 2, 3, 4, all the way up till 16 and 17 and then stopped. And that would have taken a long time. Here, this took relatively, like maybe two minutes, and that's only because I had to pause and make sure my camera was working. So this would be faster, but we just have to remember, okay, yes, the true answer is 16.5, but because I can't purchase half a toy, I can only purchase 16 toys. So they're close, but they're not exact because we had to consider logical, like real world logic. So I would like it if you pause the video and based off of what I just discussed, explain some similarities and differences between Chloe and Charlie's answers. So I'm going to stop the video for a second, or well, I'm going to pause my video. You pause your video and take a minute to answer that. Okay, so I'm not going to write down anything for 5 because I kind of discussed that in full, and that's for you. Okay, so let's start on task 3. Task 3, you will solve the following inequality twice. The first step has been done for you in bold. So let's look at the differences between these two methods. So Charlie and Chloe are both solving the same inequality. Charlie is adding 4 to both sides, while Chloe is adding 2x to each side. So I want you to pick up where they left off. So you're going to solve the same equation twice, but you're going to do it 2 different ways. You're going to solve it the way Charlie started it, and you're going to solve it the way Chloe started it. Okay? And then after you solve, I need you to answer 6 and 7. Okay, so go ahead, pause the video, and give yourself a few minutes to work it. All right, so let's take a look at just the 2 equations being solved, or 2 inequalities. So we added 4x to each side first. The -4 and +4 canceled, leaving us with just -2x. 8 plus 4 is 12. Then to get x by itself, we divided both sides by -2, and we end up with x is greater than -6. Okay, so let's look at Chloe's. So we added 2x to each side, so the 2x's cancel here, and I'm left with -4 is greater than 8 plus 2x. So we subtracted 8 from each side, and we're left with -12 is greater than 2x. Divided both sides by 2, and we're left with -6 is greater than x. So did I have the same solution? So let's look at this. This says that x is greater than -6. So possible solutions, what are some numbers that are greater than -6? 0, 4, 10, and we can list way more. Now this one says that -6 is greater than x. So that means x would be, if we wanted to put this in order, x would be less than -6. Okay? So what are some numbers less than -6? Well, we could do -10, -15, -378. Just saying. So who's correct? It's the same inequality, but we've got 2 different solutions. So did they get the same solution? No. Because Charlie has x is greater than -6. Chloe is x is less than -6. So if you were to graph these, we'll just do a quick little. Normally I would, well, let's do this. -6, we'll do -7, -5, -7, -5. So what Charlie's looks like, Charlie's graph would be everything this way. And Chloe's graph would be everything that way. So they have the exact opposite solutions. All right, so no, they do not have the same solutions. So who's correct? Because they can't both be correct, can they? So let's see. We're going to see if the numbers we chose make the original equation true. So, and we'll just pick one. We'll pick 0 and we'll pick -10. So we'll have one that's greater than -6 and one that's less than -6. So let's do 2 times 0 minus 4 is greater than 8. Well, -2 times 0 is 0. 0 minus 4 is -4. So we have -4 is greater than 8. Well, we know that's not true. So we can say Charlie is incorrect. And we can, let's do the same with Chloe. We'll do hers. We'll do -2, except we'll plug in -10 since that's less than -6. And I'm trying to pick numbers that are easy math. I like anything that ends with a 0. It just makes for easier math. All right, so -2 times -10 is +20. 20 minus 4 is 16, and 16 is greater than 8. So Chloe is correct. Okay, when it says explain, I kind of verbally explain. You could write something down that says when we checked the solutions, when we picked variable or numbers that matched their solutions, Charlie's did not produce a true statement while Chloe's did. So something like that. Okay, so number 7, Charlie looks back over his work. He says he can get the same solution as Chloe by switching his inequality sign. Do you think this is mathematically legal? Why or why not? So he's corrected this. He's like, well, if I turn my sign around, Chloe and I have the same answer. So if we think about it, our solving steps were correct in both of these. The only difference is that what we did was, the inequality symbol. So, and what order we added in. So all our steps are correct. So why is it that one solution is incorrect and one is correct? So can Charlie just flip his sign? So I'm going to give you a few minutes to ponder this. So go ahead and answer the question. Okay, so I'm not going to answer number 7 because I just kind of want you, I'm going to leave that for you to think about. So number 8, we're going to do an experiment where you would have to switch your inequality symbol. So we're going to complete this table. So I want you to pick 2 different numbers. They don't have to be the same as mine. If you want to do the same as mine for this one, you're going to do it again on the back of this page or on the next page. This is the back of one. Mine are all front-sided. I don't have backs on mine. So we're just going to pick 2 random numbers. So let's keep it easy. Let's do -5 and +10. I wanted to do one that had a negative in there too. All right, so we have -5 and +10. So if I want to write my inequality, this would be -5 is less than 10, and we know that's true. Okay, so step 2, multiply both of these numbers by 3. So if I do that, times 3 would be -15 and 30. Okay, so if I were to write this as an inequality, this would be 15 is less than, or -15 is less than 30. Okay, multiply both numbers by 4. We're going to multiply just the original numbers. We're not going to, because it's going to get to be big numbers if we keep going. So -4 times -5 is 20. -4 times 10 is -40. So when I go to write this inequality, 20 is larger than -40. So when did I swap my sign? So let's look at this. I'm going to just box this So I swapped my sign here. Okay, so let's keep going. Divide both numbers by 2. I should have picked 2 even numbers, but I didn't think about it. So this is going to be negative 5 halves, and this is just going to be 5, because I'm dividing both of these by 2. Okay, so what's larger, 5 wholes or 5 halves? 5 wholes. So this is negative 5 halves and 5, and we're back to normal because, you know, we're going back to this, so we're back to normal. So let's divide both numbers by negative 1. So negative 5 divided by negative 1 is positive 5. 10 divided by negative 1 is negative 10. And boom, our sign ends up switching again because 5 is larger than negative 10. Okay, so number 9. What do you notice about this table? What do you wonder? So I'm going to let you answer that. So go ahead, pause the video, give yourself a few minutes to jot some notes down. Okay, so again, when we ask what do you notice, what do you wonder, that's not something I can answer for you. But I would just take special consideration of what do you notice about the 2 times you flip your sign. Okay, so number 10 asks you to try this experiment again with 2 different numbers than this first time. There's a table on the next page, and for you to notice when do you flip your inequality signs. So go ahead and go to the next page. You pick 2 random numbers, do your inequality, and see if you can figure out the rule for flipping your inequality sign. So go ahead, pause the video, and just fill out this little table with whatever numbers you want. Okay, so again, when you do your table, it's whatever numbers you want, so I'm not going to fill that one out. But it asks, when do you flip your inequality sign? So you should have discovered this on your own, but if you missed it, it flips every time you multiply or divide by a negative number. So anytime when you're solving an inequality, if you have to divide or multiply by a negative, go ahead and flip your inequality sign. Okay, so if we go back to 7 where it asks, is this mathematically legal? You can't just change your sign willy-nilly, only when dividing or multiplying by a negative. And if you look here, Charlie did divide by a negative. So when you divide by that negative 2, that would switch your sign. So is it mathematically legal for him to flip the sign? Yes, but only because he divided by negative 2. All right, so I'm going to end this here. On the very end, you do have an individual practice section. So solve these 3 and make sure you graph them. Here's a little tip for you at the end. Substitute some sample answers back into the original inequality to check your work. So just like we did with these 2, we picked some numbers and saw which one yielded a true statement. So go ahead. I'm going to sign off. Make sure you get the individual practice done. Practice, practice, practice. It's going to make you stronger in math, okay? So you guys have a great evening, and I can't wait to see you again. Bye.